Here's a definition of exponentiation. X to the a power means a x's multiplied together. That is, for any real number x and for any positive integer a, x to the a power is equal to x times itself a number of times. Well, this is a great definition, but it applies to just positive integers. In this lesson, we'll look to see how exponents that are zero or negative integers work. And let's start by looking at powers of 2, and we'll start with 2 to the third, which we know is 8, and 2 to the second is 4, and 2 to the first is 2. Well, let's examine this again. To get from 8 to 4, we divide by 2. To get from 4 to 2, we divide by 2. So to go down to the next integer power, which would be 2 to the 0, it makes sense that we should divide by 2. So using this rule, 2 to the 0 power is equal to 1, because 2 divided by 2 is 1. Well, let's go to the next integer power, which would be 2 to the negative 1, and we'll divide by 2 again. And 1 divided by 2 is 1/2. So the next integer power would be 2 to the negative 2. 1/2 divided by 2 is 1/4. And 2 to the negative 3 would be 1/4 divided by 2, which is 1/8. Notice, the negative integers do not make the number a negative number, but the reciprocal of the same power if it were positive. And that brings us to this rule for negative exponents. For any non-zero number x and for any integer n, x to negative n, could also be read x to the opposite of n power, is equal to 1 over x to the n power. And if you know anything about reciprocals, you'll know that 1 over x to the n is the reciprocal of x to the n. We also have a rule for the zero exponent. For any non-zero number x, x to the 0 power is equal to 1. So any number except 0 to the 0 power is 1. This rule doesn't work for zeros as the base because of something called division by 0. And many of you already know division by 0 is considered undefined or impossible. Well, let's look at powers of 10. We go from 10 to the third and we count down to 10 to the negative third. And from one step to the next, we divide by 10 each time. So we start with 1,000, we divide by 10, and 10 to the second is 100. Divide by 10, 100 divided by 10 is 10. And then from 10 to the first to 10 to the 0, it's 10 divided by 10, which makes 1. From 10 to the 0 power to 10 to the negative first power, it's 1 divided by 10, which is 1/10. And then 1/10 divided by 10 is 1/100th, which is 10 to the negative second power. And the final one in our chart, 1/100th divided by 10 is 1/1000th, and that is the value of 10 to the negative third power. In the previous lesson, we learned that to multiply a number containing a decimal point by a positive integer power of 10, just move the decimal point to the right the same number of places as the exponent. Then fill in zeros as necessary. Well, now we can add to that definition. If the power is a negative integer, move the decimal to the left. Here's an example. We start with 623.4. We'll multiply that by 10 to the negative second power. So we find our decimal, and we move it 2 to the left. And then we write the number in a nice, neat form, and our answer is 6.234. Here's another example. 3.14 times 10 to the negative fourth. We'll write 3.14, and we'll make our 4 moves to the left. And on this one, we need to fill in zeros as necessary, and then we'll write the answer in a final neat form. So 3.14 times 10 to the negative fourth is 0.000314. Another way to say it would be 314 10,000ths. And now we can use powers of 10 to name all the places in our decimal number system. The thousands place, 10 to the third. The hundreds place, 10 to the second. The tens place, 10 to the first. The ones place, 10 to the 0. The tenths place, 10 to the negative first. The hundredths place, 10 to the negative second. And the thousands place, 10 to the negative third. And I'm sure you can figure out what to use for places larger than thousands or smaller than thousandths. Here's a number, 7,654 and 321 thousandths. Well, we can use our powers of 10 to write this number in what's known as expanded form, shown here. We have 7 times 10 to the third for the 7 in the thousands place, 6 times 10 to the second to represent the 6 in the hundreds place, 5 times 10 to the first to represent the 5 in the tens place, 4 times 10 to the 0 to represent the 4 in the ones place, and then 3 times 10 to the negative first for the 3 in the tenths place, 2 times 10 to the negative second for the 2 in the hundreds place, and 1 times 10 to the negative third for the 1 in the thousands place. In this lesson, we looked at negative exponents. For any non-zero number x and for any integer n, x to the opposite of n power is equal to 1 over x to the nth power. And the zero exponent, for any non-zero number x, x to the 0 power is equal to 1.